The last thing I want to talk to you about today is radical expressions, expressions that have a radical sign in them. And this is something that, when it's presented in algebra classes, I know is a little bit dry, and I've even had, this is a little discouraging, but I've even had Algebra 1 teachers out in the public schools kind of say, you know, what's a good use for these things? Why does somebody need to know how to use these things? So I'm going to show you a real nice application of radical expressions today, and it all has to do with finding average growth rates. Okay, let me describe a situation to you where you've inherited some stocks from a rich relative, and the shares are valued at 32 cents each at the time that you get them, but 8 years later they're worth $1.52 each. And so you're trying to kind of plot, their average rate of growth here so you can determine how much money you'll have later on when you retire. And you may even have a financial planner kind of looking at these ideas. So the question is, how do you calculate the average rate of change, the average rate of growth of these shares? So we could just simply do a calculation and divide by 8. I mean, the percent growth is where you take the difference in the new and the old and then you divide by the old. That's percentage growth up or down. And really you can think of that as new divided by old and then just subtract the 100%. So in this situation, here's the new price, there's the old price, and then you subtract the 1 after you're done dividing. That gives you 3.75, which means the stock has grown total 375%. Now, I guess you could say, well, does that mean then the annual growth is, take that, divide by 8. Is that nearly 50% growth each year? 46.875? Well, the way to test this, we talked about how to do this on a previous episode, is you say, okay, you take your growth rate, you add 1 to it, and you multiply that by your principal amount, and then to do it for 2 years, just multiply by 1.46875 again, then do it again, and then for 8 years, you would raise that to the 8th power. Well, that number turns out to be roughly $6.93. That's way more than $1.50. It should be $1.52. Sorry, it's way too high. It's way too high. Okay, so that's incorrect. That's not the correct rate of growth. We could do something like this. It has risen by a total of I don't know why I keep trying to talk in cents. $1.20 in stock. So you could take that, divide by 8, and add that to the price. Imagine it grew at a constant rate. Okay, and so it would be 47 cents after the first year. The rate of change then would be this 0.46875 that we calculated earlier. And then if you raise it by another 15 cents and get the rate of growth, it gets a little smaller. And you can just keep working this problem. Add this 15 to this, and add 15 again, 15 again, 15 again. You get these rates of growth, and you can see that they're going down each year. And then we could say, well, all right, I've got 8 rates of growth, average them up. Add them up, divide by 8. That gives me a little over 22% growth. Is that correct? Well, let's test that again. If I take that 22.004, add 1, raise that to the 8th power, multiply by my principal, I get $1.57. That's closer, but it's still too big. Okay? So clearly we're not on the right track. And I'll be honest with you, the only reason that worked out close at all is because we did things in a nice uniform pattern. Stocks and bonds typically grow kind of spurtish. They'll grow big, they'll fall, you may even lose in a year. So if you average those kind of growth rates up, it wouldn't be anywhere near the correct growth rate. Okay? What we're doing, when we're doing it the wrong way, is we're using what's called the arithmetic mean. And that's where you add things up and then you divide by the number of things. That's how you average your grades, for example. So the arithmetic mean of 4, 6, and 11, you take those numbers, you add them up, and then you divide by 3. The sum is 21, divide by 3, you get 7. Now, what that 7 tells me is, if I were to add these 3 numbers up, I would get 21. If I replace each of these numbers with a 7, I'll still get 21. Okay? What we need, actually, you'll notice that we're multiplying a number 8 times. And so we need a number that we can replace those numbers with and get the same product each time. So we're going to use we need to use what's called the geometric mean. And that's where I multiply things together, and then I take the nth root of however many numbers I have. And if you prefer, you can use this kind of exponent instead of this. This is kind of hard to find on some calculators, but you can always do this. So the geometric mean of 4, 6, and 11 is 6.41507. That's less than 7. That was the arithmetic mean. It's always going to be a little less than the arithmetic mean. But if I multiply those numbers together, I get the same product each time. Okay? So what we were doing is we were calculating percent change like this. We were actually taking 1 plus the percent change. Well, if I move this 1 over, then that's new over old. And so I'm going to be a little vague here and just say, well, okay, let A sub n be the price per share at the end of the nth year. And I'm not going to make up numbers this time. Each time, this A sub n over the last number will give me the multiplier for that year. So when I find the geometric mean of all those things, you'll notice how these lay out. I can cancel things and just take the last value over the first value, take the nth root. That gives me that multiplier. You'll notice if I plug that in, I get $1.52, which is what I wanted. And that means that I had a 21.5 roughly average rate of growth. Okay, and that's an accurate measure. Now, what we can actually do, we can take this a little farther. We can use this application in some algebra problems. You know, if I look at this business of new over old, and then I multiply both by the number of shares, well, again, that's multiplying by 1, so it's not going to change the value. So instead of doing the stock prices under that radical, I could do the values of the stocks under that radical. Let me show you how that would look. Let me do a quick little problem like that. Let's say you've forgotten how many shares you have, but you know over the last 8 years that they've grown at an average rate. This time we know the average rate is 21.5%. They're now valued at $1.52 each. And your financial guy tells you that, or gal tells you that they're actually worth $10,200 more now than then. So how many shares do you own? Is that something you've got to go look at? You probably have in a lockbox somewhere. Well, if you let X be the number of shares, then this business here, the 1.52 times X, that gives you then your total value right now. And the value then is 10,200 less than that. Again, arrange those under the radical, 8th root, and that equals 100% of what you have plus this 21.05, or converted to a decimal. You can plug those things. That's a hard thing to solve. We won't talk about how to solve it symbolically, but you can just flash them into the calculator and graph them. I'll actually zoom in on it a little bit. Use the calculator functions to see where they intersect, and sure enough, they intersect right at 8,500. So you have 8,500 shares. Nice little algebra application of radical expressions, something they told me couldn't be done. I went through a lot of stuff really fast there, so as I always do, I'll kind of end here with some summary pages that kind of hit the key points of what I've talked about.